Muy buenos días. Bueno, mi nombre es Maru Sarana y desde ADItech y en colaboración con el Servicio de I+D+i del Gobierno de Navarra hemos organizado este taller específico de dimensión de género en el contenido de la I+D+i. Como sabéis, tenemos el gusto de contar con una referente también en este mundo, con Sabine. Prefiero no pronunciar su apellido para que lo haga ella bien, no quiero meter la pata. Pero Sabine no es la primera vez que colabora con nosotros, participó en las jornadas que hicimos hace un año en colaboración también con la Universidad Pública de Navarra. Voy a empezar también compartiendo con vosotros la pantalla. No sé si estamos todos, pero bueno, vamos a seguir por deferencia también a las personas que son puntuales. Como os decía, hoy tenemos el placer de contar con Sabine como experta en investigación con dimensión de género, que esperamos que os ayude a aterrizar. Los que sabéis un poco sobre este tema os va a venir muy bien también para tener un taller práctico y poder plantear preguntas directamente a ella. Y para aquellas personas que todavía no estáis familiarizados con el tema, del mismo modo, para que podáis empezar a conocer en qué consiste y dónde tenéis ciertas referencias. Bueno, para hacer ágil el taller, por favor, mantened en todo momento la cámara apagada y los micrófonos apagados, por favor. También, como sabéis, tras la parte teórica, bueno, yo voy a hacer una brevísima presentación y tras la parte teórica de Sabine, ella os va a ir alojando en distintas salas. También veremos cuánta gente estáis al final para que pueda hacerlo correctamente. Donde también vais a plantearle y ella va a ver exactamente también en qué punto estáis. Luego os volverá a llevar a la sala común hacia el final de la presentación para que pues eso, pongamos todos en común o pongáis tanto dudas que sean reiterativas entre vosotros como cualquier otra cuestión. Aproximadamente acabaremos a las 11:30 de la mañana. Entonces, por favor, como os decía, mantened ahora en esta parte primera las cámaras y los micrófonos apagados. Por mi parte, os voy a hablar muy brevemente, para los que no nos conozcáis, aunque creo que la mayoría de vosotros. Este es un taller enmarcado para contribuir a la excelencia científica. Se ha diseñado con el Servicio de I+D+i del Gobierno de Navarra específicamente para los doctorandos y doctorandas industriales. Pero también estáis muchas personas de investigadores e investigadoras que no sois doctorandos, quiero decir. Entonces, SINAI, ADItech, como sabéis, es el coordinador del Sistema Navarro de I+D+i, que es bastante heterogéneo, pero bueno, son todas las entidades que realizan I+D+i en Navarra. Y dentro de los pilares de ADItech, que son 4, uno es la colaboración, intentamos fomentar esa colaboración entre todos vosotros, otro es la excelencia, otro es la internacionalización y otro es el acercamiento a la sociedad. Dentro de esta excelencia es donde englobamos y enmarcamos la iniciativa de investigación con dimensión de género, que como veis aquí a la derecha, ADItech tiene otra serie de iniciativas, pero la que hoy estamos, en lo que enmarcamos el taller de hoy es en esa excelencia científica. Os voy a dar unas pinceladas del marco legal, porque diréis, ¿esto de género qué es? ¿Esto solo consiste en que haya equilibrio de mujeres y hombres en los equipos investigadores? ¿O quién se ha inventado esto? ¿Por qué es importante o por qué no? Para eso os voy a dar un barrido rapidísimo de esos mandatos o esos marcos legales que nos obligan a todos y que os obligan a vosotros y a vosotras también como investigadores, como científicas. Uno de ellos es la Declaración Universal de los Derechos Humanos, donde dice que todos y todas tenemos derecho a beneficiarnos de esos materiales resultantes de la producción científica. Por defecto, como sabéis, o quizás ahora se empieza a hablar cada vez más de que se está mirando, se está haciendo un análisis más exhaustivo de cómo se ha hecho la ciencia y qué se ha dejado en el camino y qué resultados se han extrapolado cuando se ha hecho análisis basándose en un estándar de hombre o un estándar masculino en general. Entonces, bueno, pues para que también nosotras, ¿no?, las mujeres, como un derecho universal, y todos y todas tenemos el derecho de beneficiarnos de los resultados de las investigaciones y de la ciencia en general. Asimismo, aunque sé que Sabine se meterá también en este tema de lleno, sabéis que en el Espacio Europeo de Investigación hay varias prioridades y una de ellas es esa transversalidad de género. Y de los 3 objetivos específicos os destaco en negrita el que nos ocupa hoy en el taller, que es esa integración de la dimensión de género en el propio contenido de vuestra investigación, desde la hipótesis del proyecto y durante todo el proceso y en los resultados. Y aquí a la izquierda os ponía en otros países, aparte de la Unión Europea, desde qué años se obliga a justificar o incorporar esta dimensión de género. O sea que, como veis, aunque ADItech empezó con esta iniciativa en el 2019, cuando todavía realmente casi nadie había escuchado hablar de ella, afortunadamente cada vez vemos que aquí, por lo menos en el 2022, y Navarra es pionera en este sentido, estamos avanzando mucho. Y nos podemos sentir orgullosos de que, aunque hay países que nos llevan ventaja, estamos por el buen camino. También, por supuesto, en la modificación de la Ley de Ciencia y Tecnología, que era del 2011, pero que habla de esa transversalidad y esa incorporación de la dimensión de género en el contenido a nivel nacional, pero así también, por supuesto, en la Ley Foral de Ciencia y Tecnología, y en la Ley Foral de Igualdad, que también nos aplica y nos obliga en distintos ámbitos. Todo al final está intrincado y se refleja en, por ejemplo, las convocatorias de ayudas del Gobierno de Navarra, en una serie de requisitos o criterios que, como habréis visto en distintas ocasiones, como los proyectos colaborativos, os obliga por lo menos a cuestionaros si estáis incorporando esta dimensión, y luego, si decís que sí, cómo lo estáis llevando a cabo. Por otra parte también, que sepáis que ADItech intenta hacer esta recopilación de conferencias y materiales que son específicos para vosotros también, que os pueden servir, entre ellas 15 conferencias que tenemos en esta sección, en la sección de dimensión de género de la web de ADItech, donde tendréis también una guía muy simple que está bajada en las directrices SAGER, donde os indica en castellano además esa terminología y ese pequeño esquema que debéis seguir para incorporar esta dimensión en vuestro proceso investigador. Luego, sin más, antes de pasar a dar la palabra a Sabine, quería deciros que de aproximadamente, los datos son de ayer, 105 inscripciones para el taller de hoy, aunque ahora veo ahora mismo que estáis 46 personas escuchando. Así se reparte entre hombres y mujeres. Un 64% de las personas inscritas son mujeres y un 36% eran hombres. Y por otra parte, para el 60% de las personas inscritas es la primera vez que reciben formación en este ámbito. El 40% afortunadamente ya ha recibido alguna formación. Pero ahora, si lo desglosamos por hombres y mujeres, me parecía interesante también mostraros que el 48% de las mujeres que se han inscrito a este taller ya han recibido en algún momento alguna formación en investigación con dimensión de género, mientras que ese porcentaje en hombres se reduce al 30%. Y por otra parte, las mujeres que por primera vez reciben, como hoy, un taller específico de dimensión de género en la investigación, son el 52% de las mujeres, Y sin embargo, de los hombres que se han inscrito hoy, el 70% de ellos es la primera vez que escuchan hablar y que reciben una formación, un taller como el de hoy. Entonces, bueno, sin más dilación, tenéis mi email aquí. Cualquier duda, consulta o inquietud o referencia, aunque os pasaremos también las presentaciones a posteriori y también la grabación de esta sesión la colgaremos en esa web que os hemos indicado. Que sepáis que ADItech intenta contribuir a esta excelencia vuestra, pero sí que es cierto que el paso no lo puede dar ADItech por vosotros, sino que cada uno en vuestro ámbito específico de investigación tenéis que ser capaces de empezar a haceros unas preguntas, unas hipótesis que hasta ahora no os habíais hecho. Y esperamos que precisamente con la presentación de Sabine, tanto la parte teórica como luego los grupos que va a dar paso y las preguntas que vais a poder hacerle y ese diálogo que vamos a poder mantener con ella, que por lo menos hoy os sirva como punto de inicio para la mayoría, pero como continuación para las personas que ya habéis empezado a buscar bibliografía específica en este ámbito, en vuestro ámbito de investigación, para que cada vez sea más fácil que lo incorporéis y lo apliquéis de forma práctica en vuestros ámbitos. Así que muchas gracias y doy paso a Sabine, que ella, como sabéis, como ya he indicado, es experta y referente en dimensión de género en el contenido de la investigación. Muchas gracias, Sabine, cuando quieras.
Okay. Well, thank you very much. That's not me. Okay, now should be okay. So yeah, well, thank you very much for the introduction. I will switch to English now. I understand what you say, but my Spanish is definitely not good enough to keep speaking in Spanish, so we will have to move that to English. But if there's questions, I'll probably be able to understand them just fine in Spanish as well. Okay, thank you so much for the invitation and for the opportunity to be with you here today. I will share my first screen. And I have just one question to the organizers. I hear a sound every time somebody enters the waiting room, which is wonderful and makes me realize how many people are still joining us. But if it's possible to mute that, that would be great because it keeps coming up during the presentation. So if you can have a look at that, that would be great. If it doesn't work, no, but yeah. Well, regarding myself, maybe some of you know me because as Marusha just said, I already did a training with your organizations before, and I've been in this space for quite some time. So I've been working in this field for 15 years, a little bit more by now. I'm based in medicine. So my background is as a physician, but then I also studied public health. I also studied organizational consulting. And so I would just say my profile is a bit bigger than that. But of course, I'm based in the biomedical field. So most of the examples I'm going to show you today come from the biomedical field, although there's a few that I think are directly transferable to other fields as well. And especially the theoretical part I'm going to spend quite some time on, I think is applicable throughout anything you're doing, because really what we're seeing in medicine, and this is something that is pushing some of the other natural sciences as well, is that we need clear ideas about it is what we're actually doing. What is it that we're actually measuring, and how does it affect our work? So I think that part is directly transferable. I'm pretty sure some of you might recognize this as relevant for their work as well. I work between two countries, as you can see here. I have two professorships, one in the Netherlands and one in Germany. So I spent my time between these two countries. I'm mostly based in the Netherlands. But as I said, I also spend half of my time in Germany, but not physically. I also work with the EU Commission. Some of you might know Gendered Innovations, the website. I'm going to say 2 words about this at the end of the presentation. So I'm a regional co-director for that as well. And yeah, I think that's kind of my profile. And if you have any questions about that later on in the discussion, please feel free to ask what it is that I am doing and how I got there, because these are also questions that I do get sometimes, and I'm happy to answer to those as well. Now, what do I want to talk about today? First of all, well, what the gender dimension is, we already heard a little bit about it in the introduction, but there's a few points I want to pick out also to highlight why it is important for your work, and why the funding organizations really want you to do this. And since most of our work depends on funding organizations in one way or another, you will probably find yourself having to comply with these requests. Then I will move into what sex-specific analysis for research and innovation means. So what is it when you do sex-specific work, when you do sex-specific research and innovation development? And then I'm going to do that with gender as well, which is quite complicated still at the moment. And I would say that probably the methodology that we're developing in the medical field is mostly applicable to other natural sciences and engineering more than a lot of the background that has been developed in the social sciences, which might be more tricky to apply. I will give you a number of examples about what can possibly go wrong if you don't do it, so that, you know, if I haven't convinced you with the theoretical part, we're going to go into the practice and have a look at what happens if you don't consider that, and hence why is it important to think about this and incorporate that in the work we do. And then I'll finish with a few thoughts about the connection between content and context, and you'll see what I mean with that once we get there. All right. If there's any relevant question towards understanding during the presentation, feel free to put them in the chat. I would ask Marusha or anybody else from ADItech to let me know, because I cannot monitor the chat while I present. But if there's any direct questions, please let me know, and I'm happy to pick those up. And I think anything that goes more in detail, we can move to after the presentation. And I will dive right in. So what you see here is a bit of a historical path to sex and gender sensitive research. So what has happened and where are we right now? So we've, together with a colleague of mine, we've recently done a summary of what has happened over the years. And you see it really starts sometime in the 60s and 70s with the women's health and right movement, focusing mostly on reproductive health and reproductive access and equality. It then moved over to the direction of gender mainstreaming sometime around the 2000s. You can also see that the US and Canada have been a bit ahead of us in Europe, but then Europe catches up, especially when it comes to the legislature. So in the years 2000 up to 2010, we have a lot of directives that have been published and presented, both for the biomedical field, but also generic gender mainstreaming policies. You see, for example, the ERA, gender equality and gender mainstreaming and research priorities. So that goes way beyond the biomedical field, as really for the whole of the research environment. And here is where we are right now, where we have a number of policies in place in a number of countries. At the EU level, it's mostly at a supranational level, so mostly at the EU level, but single countries, as you just heard in your presentation as well, are trying to implement these guidelines, or in a way also these best practice examples from the EU level at the national level. So we're seeing kind of a trickle down effect and translation of some of the things that happen at the EU level at the national level. And this is where we are right now. What does that mean for us? So why do we need to do this at all? And why are you doing this workshop today? Because there is a growing interest in the topic, and there's a growing recognition for its impact on health and on innovation and on research in the broadest sense. And that reflects in some statements by the funding agencies. What you can see here, this is the statement from the European Commission in the programs Horizon 2020 and Horizon Europe, where they say that while focusing on sex and gender improves the scientific quality and societal relevance of the produced knowledge, technology, and innovation. So it's not just medicine, it's really anywhere in the innovation cycle. These are the Canadian Institutes of Health, which mostly focus on rigor, reproducibility, and generalizability, and they talk about excellence. And then the US NIH says that considering sex and gender enhances the reproducibility through rigor and transparency. So if we think about this, we're not talking about like some small things that we can achieve by focusing on sex and gender. It's actually pretty big topics in the research field in general. So reproducibility has been quite a topic for some years now, especially moving through a reproducibility crisis where a lot of work is being published and cannot be reproduced, and having more information about sex and gender can help mitigate some of this. It is really about producing excellent work, about producing work that complies to the highest standards, and most importantly, that has a societal value. So societal value hasn't really been a huge topic until 10, 15 years ago. But in the last 10, 15 years, with research costs exploding and with in general a focus on what is it actually that we're doing in research and in how far can that benefit society overall, the topic of societal value has become more and more relevant. And of course, you can imagine that if you produce research that is valid and applicable to the whole population rather than just a small subgroup, you're of course producing much more societal value and producing things, products, innovations, and services that can be applicable in broad terms. So it is important, at least for them. So these are not my words, I'm just quoting the funding agencies. This has already been mentioned, and I think it's important to pick this up again because it has two components to it. So if you look at what the European Commission wants you to do, you'll see there's two layers that are at the context level. So the EU wants you to foster gender balance in research teams. So that is who is in the team. The second layer is looking at gender balance in decision making. So who gets to decide which kind of research questions are being asked, which kind of products are being developed. And the third one is focusing on sex and gender specific analysis in research and innovation. And this is mostly what we're going to talk about today. So what the EU Commission really shows you here is that there's two layers you can address. One is who is doing research and how questions are being framed, which kind of priorities are being set. And the other one is really the content part we're doing. As I said, today we focus mostly on this, but we cannot completely ignore this part because it affects what we do at the content level. Now, what does it mean to look at sex and gender in research? So how do we frame it and what do we work with? I start with this first figure that you'll see again throughout the first part of my presentation, just to give you a bit of an orientation of where we are. When we look at the impact of sex and gender on research, we're really looking at different dimensions. So what you see here in the middle is the sex part, where we look at biological differences, we look at hormones, at genetics, at physiological differences, and I'm going to go in the detail of that. So this is mostly relevant if you work with cells. It is relevant if you work with animals, although there might be some additional dimensions here. It's important if you work with tissues. So everything that is kind of not the whole of the person. As soon as you work with humans and as whole, so let's say you do clinical studies or you do qualitative work or you try out some product and you want to have feedback from people, you work with human beings. And human beings don't exist in a vacuum, but they exist in a society with other people around them. And that's when gender comes in. So gender are all these things around the strict biology. And what we like to do in medicine in order to be able to measure that, at least partially, is to divide it into different dimensions. So when you look at the measurement of gender in the natural sciences, you will find 3 or 4 layers at least, if not more. And the first one is gender identity, which is, is a person a man, a woman, a non-binary person. This is really their identity, who they are, how they identify, and it's something you can only find out if you ask them. The second one is the role or the norms, which is what society expects us to be. So what does it mean to be masculine or feminine in Spain in the year 2022? And I would also differentiate where you are in Spain, for example. So it is connected to our communities. It is connected to the time and place. And it is a fluid concept. So understanding of what masculinity and femininity are changes over time, but it affects how society sees us and what we get to do. So for example, in the interaction with the healthcare system, what is projected on us as potential female diseases or male diseases impacts how fast a diagnosis, for example, is made. Then we have the third layer, which is the relations. And in this case, you basically can imagine it like a combination of these two. So when my identity is met with what people expect me to be, how does that affect my interaction with other human beings? And that can be in the personal space, so in the private, at home. Let's say the kids are sick or relatives are sick, who in a partnership gets to stay home and who gets to work? It can be in the professional level. You have to negotiate a new salary. Which kind of assumptions are being made about you? Are you allowed to ask for a higher salary, or is that against unwritten masculinity and femininity roles. So are you going to get more money? And then there's, of course, the societal level, the public level also, in how far does that affect your interaction in society in a broader level. There is a fourth level, which is the institutional gender, which means that basically all our organizations and our societies are designed according to certain gender perceptions. The way our laws are written are not neutral. The way our organizations are built, the way we work is not neutral. So there are gender aspects in all of this that we might know about or see, or we might not see. So this affects on a higher level the societies we're living in. Today, I'm not going to focus on this because it goes a bit too far, but it's important to keep that in mind, especially if you work in an organization, if you work in a certain system, you work in a certain political system as well. These things are there, whether you want to see them or not. Now, let's start with the biological part. And this is half of a slogan of the Canadian Institutes of Health Research that say every cell has a sex and every person has a gender. So that I left out because we're starting with sex here. And what you can see already is I placed the X and the Y chromosomes everywhere in the body. Because regardless of what we've learned in school or what we've learned in university a longer time ago or a shorter time ago, these chromosomes are not just relevant for the reproductive organs, they're relevant for the whole of the body. Now, let's think about how we operationalize sex. It seems easy. I'll probably show you that it's not as easy as it seems. So a lot of times when people say I analyze data based on sex, they think, okay, I compare females and males and I'm done. Well, but there's different ways to define female and male. And we need to be mindful of that, especially if we want to do good research. So there's at least 3 ways to classify sex. And the most commonly used are genetics, so looking at chromosomes. The second one are the gonads, so looking at hormones. And the third one is genitals, looking at the genitals of the person and saying, okay, this is female or male. So let's have a closer look at each of them. The first one is genetics, which is probably, and I say that in quotation marks, the easiest way to define sex, because what we assume is individuals are divided into XX and XY, and in most of the cases, XX are female, and in most of the cases, XY are male, and in most of the cases, XX might identify as women and XY as men. It's not always like that, but in the majority of cases, it is like this. There are, however, already some exceptions to this rule. So the world is not 50-50 strictly XX and XY, because we know in medicine that there are already some exceptions, even if we only look at these chromosomes. There are individuals that only have one X chromosome and thrive, they become adults. It is viable. So these are people with Turner syndrome. Having only one Y chromosome is not viable. So you don't survive into adulthood if you only have a Y chromosome. But you can also have more copies of the X chromosome. So there's individuals that have 2 copies of the X chromosome or 3 copies of the X chromosome in their cells. Both of these are quite rare, so they're not very common. But these are people that survive into adulthood. We have them into our society, so it's not impossible to have a different correlate, which is not XX and XY. And that already makes it a bit more complicated. But then, even more interestingly, our chromosomes are not fixed in time. So in the past, we thought, well, that's the chromosome setup and it stays like this forever. But by now we know that if we analyze blood cells, so rapidly dividing cells, there are certain cells in our body that don't change that much, but there's also cells that are renewed very frequently, for example, blood cells. And if we look at the blood cells of people over 60 or 65, it is very likely that we will find a certain degree of cells that only have an X chromosome or only have a Y chromosome, because as we age, the monosomy, it is called, so you have only one of those 2 chromosomes, in these cells is not a rare event. And we've started looking at that 20 years ago in the field of autoimmune diseases, where having more monosomic cells might associate with a higher risk of having an autoimmune disease. But in the meantime, there has been research on having Y monosomy, so only having cells with only a Y chromosome, which might associate with a higher incidence of cardiovascular disease in men. And it might also associate with a higher prevalence of tumors. So even in people who are born XX or XY, over time in our lives, this might change a little bit. So even this construct, which is the most binary of them all, is not fully binary, and there's an entire spectrum, and there's changes over life. Our bodies are not fixed in stone. Let's move on to the second one, and here it becomes a bit more messy. So this is called gonads or hormones. It's the second G, and it is another way to measure sex. So what we can do is we can measure hormones. Now, apart from some exceptions, there are some people who don't produce certain hormones, but in general, everybody produces all hormones. We all produce all kinds of hormones, but we produce them in different concentrations. And these concentrations vary throughout the day, throughout the months, and throughout our lives. So for example, throughout the day, if we measure testosterone levels in the morning and we measure them in the evening, they're different and they fluctuate throughout the day. If we measure estrogen and progesterone throughout the month, especially in individuals who are menstruating, who are not postmenopausal, we will find differences of fluctuation. And of course, as we age, we go into menopause or andropause. And so the production in general of these hormones declines, but not from one day to the next. It's a slow process. But that just means that if we want to define sex by measuring hormones, we need to think about when it is that we're measuring these hormones, and how it changes over time as well, and what we want to know really. And this is not just important for reproduction. So in the past, we thought, well, these hormones are mostly important for either reproduction or secondary sexual characteristics. But by now we know that actually hormones do a lot more than that, and calling them sex hormones might actually be restricted, because most genes in our bodies have receptors for these hormones in their promoter regions. So estrogens, for example, can actually impact the production of proteins that have nothing to do whatsoever with sexual function. And one interesting example that I'm showing you here is the impact of hormones on the production of immune cells or the activation of immune cells. What we can see here is a graph of the menstrual cycle. So we have a follicular phase where estrogen is high, and we have a luteal phase where progesterone is high. And then here we will have menstruation. And depending on where a person is in these two stages, you will have a different immune response. So the T helper cells, which are cells that help the production, mounting an immune response, will be activated in different subtypes depending on which phase of the cycle you're in. So in the follicular phase, it is more likely to be a Th2 response. So antibody production is the main goal here. While in the luteal phase, we're focusing more on a cell-focused immune response. Makes sense biologically because every ovulation can possibly lead to a pregnancy. And if there is an early phase of conception, you might not want antibodies circulating that could possibly harm that embryo and then fetus. You rather want cellular immunology. So there is a reason to this. But this is just to say that hormones, sex hormones in this case, can affect processes that have nothing to do with reproduction whatsoever. The third part, and this is how most of us have been attributed to sex at birth. As babies were born, somebody looks at us, they count if we have 10 fingers, they count if we have 10 toes, and they look at our genitals and say, okay, this looks male and this looks female. In most cases, this is perfectly fine because the external genitals will match our internal genitals. So in a way, it is a good way to divide on a population level. However, there are individuals where looking at the genitals, we don't know exactly if we can attribute them to female or male. And these are individuals that fall in the realm of intersex or differences of sex development. Depending on the statistics you look at, and they can be quite different depending on how it's classified, it can be anywhere between 0.05 to 2% of the population. In principle, there's a lot of medical reasons for being intersex or having a difference in sex development. In practice, this means that in these individuals, the external and the internal genitals might not match. So it has nothing to do with gender identity in this case. We're not talking about individuals who are trans. We're talking individuals where the biology of the external and the internal genitalia might not match. Now, is this an absolute exception in the mammalian world? So how is it with other mammals that are close to us? And that's why I have a mole here. Moles are very cool animals. But in principle, moles, and we didn't know that, we found out a few years ago, female moles are by default. So all female moles are intersex. So female moles have testicular tissue in their womb, and this testicular tissue produces testosterone. The female mole is fertile. So they have ovaries, they can reproduce, they have pups, everything works as if. That's why people also didn't know. But they also have testicular tissue in their womb, and this produces testosterone because this testosterone is necessary to grow their arm muscles in a way that allows them to be strong enough to live under the soil. So there is really a biological adaptation in order to allow them to lead the life they want to lead as moles. So these are animals which by default are intersex. So in the mammalian kingdom, it's actually not that rare. There might be other animals we just don't know about. Finding out that the female mole is intersex was also a chance finding, which actually surprised the researchers themselves. Now, why is this important for the work that you might be doing in research? Well, because sex can affect the cell work, for example, that you do. So first of all, a lot of people don't know the sex of their cell cultures. And as I said initially, the genetics can have an impact on things that are not necessarily related to genetics, and they can change over time. We also know that cells that stay in culture for a long time change their karyotype. So for example, tumor cells, when we work on finding, let's say, cures for cancer, we have these tumor cells that we keep in culture for a very long time. So they are passaged every once in a while, and we keep them for years at times. And there has been a few publications some years ago showing that some of these tumor cells, which have been in culture forever, have very strange karyotypes. And so they might have 3 or 4 copies of certain chromosomes. They might be lacking some chromosomes altogether. And this applies to all the autosomes, and it also applies to the sex chromosomes. So it might well be that cells that you have in culture for a long time have a strange karyotype. So check for that if you want to do that work. Furthermore, we have new techniques that we're using. So for example, reprogramming, which means we take some cell from, for example, the skin, so cells that are easily accessible, skin or blood. We put them in a petri dish, we put some factors on them, and we transform them into another somatic cell. So you can go from a skin cell, you bring them back to pluripotency, so they become stem cells, and then you transform them into neural cells, for example. In this process, the X chromosome is changed because it goes back from being mostly inactive to becoming active to being inactivated again. And this might change completely what you will find at the end. We also know that the media we give cells might have them grow differently. We know that some coloring methods might impact the estrogen receptor, for example. So there's a lot of things we do with cells that are impacted by sex or that impact the sex specific hormone receptors in the cells, but we don't take them into account, and they can impact our results. So this is where the reproducibility comes into play. It's not as easy with animals as we thought. So in the past, we thought, well, we use animals. It's much easier working with animals than humans. You know how many you have in a cage, they're inbred, you know their genetic makeup, you can decide what they eat, how warm their cage is, and so forth. You can control everything. Well, turns out that there might be sex differences here as well. First of all, the social dynamics in the cages are different depending on sex. So depending on whether you only have females or you only have males, depending on which type of mice you have or rats, they will act differently. We know that the diet can play a role. So if you feed, for example, soy-based soy-based food to the animals, this is an estrogen mimetic. So soy, that's also the reason why for some postmenopausal women, they take phytoestrogens, which is really plant estrogens that are based on soy. So these soy-based diets mimic estrogens, so they can have estrogen effects. We know that room temperature and sound could have an effect. We don't have good data on that yet, but we know in humans, for example, temperature is perceived differently, and the preferences for room temperature are different in women and men. And then there's the part of the researcher, which I'll come back to in a second, because also who we are as researchers might impact how our mice or our rats react. And this is what I wanted to talk about here. So when we have researchers working with mice or rats, the mice or rats, and we didn't know that before, we found out about 10 years ago. And if you have time and you're interested in this, this is a very good paper describing what happened. It's from Jeff Mogul's lab in Canada. Basically, the pheromones that are produced by the investigator have an impact on how your mice or rats will react. So in Jeff Mogel's lab, they investigate pain. They look at how animals react to pain and also how they react to painkillers. And what they found was that basically, depending on who was doing the experiments, on the pheromones of the experimenter, the mice and the rats would react differently, especially the female mice. So that opened up a whole new dimension of questions that we need to ask, because in the past we thought, well, you know, the mice smell each other or the rats smell each other, but what we do doesn't really impact them. Well, it turns out it does. And in the meantime, some of these data have been reproduced by other labs that are not affiliated with the initial one. So it seems to be something to be mindful of, especially if you're interested in animal behavior, because this has an impact on their behavior, not so much on, let's say, if you do just a surgery, but it has an impact on their behavior. Now, what does that mean? In summary, if you think about sex and if you want to analyze that and if you want to report it, because the SAGER guidelines have also been mentioned before, you should think about whether sex has a potential effect on what you're doing. And as I showed you, there's a lot of effects, which we are usually not taught to think about before. So think about whether there is an effect. Once you do your experiment, well, think about how you set up your experiments. How many subjects are you including? How many cells? How many animals? And break them down by sex. Seems easy, is still not always the standard. Then ideally, we would like to know confounders. I just showed you that, you know, even working with animals, housing condition, what they eat, light and dark, temperature can play a role. So make that visible so that other people can reproduce it. Ideally, we want you to analyze by sex or by disaggregate by sex and then report it. I cannot strike this enough. Now, in a lot of studies, we know how many female and male participants we have, but then in the analysis, everybody's still thrown together. So we would like to have disaggregated analysis. And of course, we want to know, what does that mean? Now, if sex isn't easy to analyze as much as it seems, gender is a whole different level. I already talked a little bit about what these dimensions mean, and now I'm going to go a bit further into what does that mean when you do the work? How can you measure it, and what could it mean? Now, when it comes to gender identity, as I said initially, it's really something you need to ask the people participating. So there is more and more surveys that actually use this two-step approach. And in this two-step approach, we ask about sex assigned at birth, which I just showed you, you know, the genitals we're looking at. Female, male, intersex, prefer not to respond. And then the second question is, what is your current gender identity? Knowing that the gender identity might change or might, let's say, be there before, but not reported before. So this can change in time. And here again, you can ask people, are you a woman? Are you a man? Are you non-binary? Are you queer? And so forth. And it's important that if you do this, you actually work with your target group and you see which kind of words they like to use, because this is not the same everywhere. And there are certain discussions also in different, I'd say, queer communities about how they would like to be addressed. So really try to be mindful of who you're working with. Why is this important? Because even if you analyze something as simple as side effects of medications, you might need both of these data. Because if I want to look into potential differences in how the liver works and hence how a drug is processed in the body, I'm interested in the sex assigned at birth, because these are most likely physiological differences. So I want to know if there's a difference there. If I'm interested in knowing whether people who report side effects are being taken seriously about their side effects, I would like to know about gender identity, because this probably has nothing to do with the biology, neither of the doctor that's listening to them, nor of the person reporting. It might well have to do with the gender identity and the assumptions towards the patient that I have in front of myself. So both of this information could be relevant even in analyzing something like, for example, side effects of medications. The second layer, and I'm only showing you some spotlights here so that you get an idea. Of course, any of this could take 3 hours just to analyze, but it's to give you an idea of what it means. The second layer is gender roles or gender norms, which is really what society sees as feminine and masculine, as I said before. And what I'm showing you here is a historical artifact. So this is the Bem sex role inventory, which, as you can see, is named after a Sandra Bem, who developed this in the 60s and 70s in Berkeley. And what she did is she asked psychology students what femininity and masculinity were like. And they came up with all kinds of very stereotypical definitions, which was a bit of what they were going for. And what she did, and I think that's important, she definitely moved the analysis of masculinity and femininity from one layer to the next. So because before this, the assumption was that there is one level, and at the end of this level, there's femininity, and at the other end, there's masculinity. So people were either very feminine and then not masculine, or the other way around. And what she did with these instruments, she showed that masculinity and femininity are actually two layers that are present in every person. So I can score high on femininity. I also can score high on masculinity. Every one of us is an individual in that respect with different characteristics. And she definitely made a huge impact with that because it changed a lot of the thinking at the time, just showing that every individual can have different characteristics. Now, there's a lot of criticism towards the BAM sexual inventory as well, whether it can still be used. It's all valid, but it has still been used about 130 times in medicine. So it is quite wide use, and it's good if you have seen it at least once and have an idea what we're talking about. The third layer I talked about were gender relations. And the one thing I want to stress when talking about gender relations is you should always have at least two measures for gender relations. Because what people will tell you directly is different than what the numbers will look like. And this is a good example of this. This is a survey that was done in heterosexual couples in Sweden. And they were asked how equitable their partnership is. So how gender equal is your partnership? And what you see here is on the brown bars, it's what people said when they were asked directly, how equal is your partnership, right? And so you have most men saying it's quite equal or totally equal, very few say non-equal. The women have a slightly different opinion, but in principle, it doesn't diverge that much. But then they also had to fill out a questionnaire where they actually had to put down numbers. So they were asked, how many hours do you work and are you paid for? How many hours of unpaid work do you do? How many hours of care work? If your kids are sick, who stays home? A lot of number of questions like this. And what you can see here is that the results from this index that actually looked at the numbers are quite different than what people say themselves. It's not that surprising, but it shows you that's important to do it at two layers, because what's happening here is, especially gender equity, is a question that's very much bound to social desirability bias. So in Sweden, for example, in the Nordic countries in general, gender equity and gender equality are important topics socially. So people will tell you more willingly, yes, my relationship is equal, because that's what's expected of them. However, it is much more difficult to say the opposite, and you will need numbers to show that. So if you want to analyze gender relation, and this is in the private, of course, you can do that at the professional level, and in the public, as I said, it's always important to have different questions that can combine. In the last few years, I'd say like 5 to 10 years, people have started to try to bring together different elements in developing gender indices. This is one example. It was one of the first with all its advantages and disadvantages, but it was one of the first that definitely kicked this off, and it was developed by Luis Pilote in Canada. What you see here is some of the things I just showed you. So for example, who's the primary earner in the household? How much money do they make? The BAM sexual inventory, and a combination of all of that gives them a probability from 0 to 100% of being a woman. We could discuss this. The index is not perfect, but it definitely kicked off a number of new initiatives in this space to try to understand how can we measure gender in fields that work with quantitative data. The last slide to this, and then we go to the examples. I just showed you how to measure sex and gender, and I'm very focused on this because it's really important that as we move forward, we get the methodology right. Because in the past, there has been a growing attention, but also a lot of confusion about what it is that we're measuring. So there's people looking at cells, telling us about the gender of the cell. There's a lot of work in where people start talking about gender, but you really have no idea what it is they're measuring, which makes it very difficult to reproduce and also difficult to talk to colleagues about. So what is it that you're actually doing? So I think this methodological part is very important, and also for you going forward, so that you can clearly say what it is that you measured and others can reproduce it, or maybe not, but at least you can have a scientific discussion where it is clear what your variable is. However, so that's an artificial division that we're kind of doing to measure these things. The reality is, of course, complex. So in the reality, in the world we're living in, and I said initially, we don't live in a vacuum. Of course, there is an interrelation between sex and gender. So we see in the beginning here, this is the baby with the genes, the gonads, and the genitalia. So here, sex. And this baby is going to grow up in a world where within their family, their community, institutions, and laws, there is gender in the system. So of course, they're exposed right from the beginning to gendered assumptions in their household, in their community, in their school, in their university, in their workplace, and in their life, which leads to different opportunities in society and in the healthcare system. So gender interacts with other dimensions, for example, age, for example, ability, class, and race. And this leads to the fact that not all humans have the same opportunities in our societies. We have societies that are simply not as equal as we would like them to be. This affects society as a whole, but of course it affects healthcare as well. So as groups, we have different opportunity to access healthcare. We have different opportunity to lead a healthy life. Do you have enough money to buy organic fruit? Maybe not. So maybe you want to live a healthy life, but simply your means don't allow for that. And that has to do with inequities in society. So all of this happens at a broader level, but it affects the individual at the end of the day as a member of this group. So all of this is intertwined and it is difficult to tear apart. But what we do in research a lot of times is we kind of try to separate out so that we can pinpoint what it is that we're doing. All right, now there was a lot of theory initially, and I would like to move a bit to the practical examples and kind of bring together some of these things and what happens if you don't do it. So the first part, and I already mentioned that before, I like to mention it twice because it's important to focus on that, is the reproducibility question. We talk a lot about different factors. We almost never think about the role of the investigator with the animals. And we might have to think about reporting who does experiments, of course, in an anonymized way, when we are reporting this. Can we do this? How should we do this? And so forth. But so just to say that sex in the most unexpected ways here might impact reproducibility. Let's move on to the second layer. So this is the one that most of you probably know about. When we think about medicine, we think about medical bias, the gender data gap, the gender access gap, and so forth. Now, this affects a lot of diseases in medicine. One of the most known one is, for example, bladder cancer. So bladder cancer is notoriously under and delayedly diagnosed in women, which has to do with the fact that a lot of times when, as a woman, you go to the doctor, you say, okay, I see blood in my urine. The first thing we think about is a urinary tract infection, which makes sense because, of course, the most likely thing is that you have a urinary tract infection. Epidemiologically, it makes sense. However, if after a while nothing helps, antibiotics don't help and anything, you still have symptoms, the doctor might have to switch to a second layer, start investigating if there's not something more than a urinary tract infection. Unfortunately, this still happens too late, which led to the fact that a lot of women were diagnosed later or too late with bladder cancer. When it comes to diseases like asthma, for example, we have a pretty clear idea of what, the symptoms of asthma look like, what a person that has an asthma attack sounds like. I can imitate this here, when you cannot breathe properly. That's typical for young boys. Young girls don't have that as much. So a lot of young girls have asthma, but they actually have dry cough at night. They don't have this typical wheezing. So the symptomatology we're looking out for might not work for everybody. The third layer are diseases that are associated with one sex or another one. So historically, cardiovascular disease has been seen as a typically male disease, but we also have diseases that we see as typical female diseases. So osteoporosis or autoimmune diseases. So osteoporosis is seen as a disease that affects postmenopausal women. This is how we see that, the images we have that we associate with osteoporosis, which is true because the most affected population are postmenopausal women. However, 30 to 40% of men over the years of 70 also have osteoporosis, which is a large number. We're talking about, millions of men with osteoporosis running around out there, but we don't screen them. So we don't know, because although some professional societies have advised for years to also screen men for osteoporosis, it simply is not happening yet because it might not be cost effective and because it hasn't really spread as much that men are affected as well. And the last story, the fourth point, is medical bias, I would say. So this is an example from a study from Israel where they looked at patients with multiple sclerosis. So multiple sclerosis is an autoimmune disease, which is difficult to diagnose because a lot of times people start having some symptoms, then they might go away and they might not have any symptoms, sometimes for years, then they have symptoms again and so forth. So it is difficult to diagnose. But that also means that as physicians, we are confused. So we send patients to a number of specialists trying to figure out what's going on. And what is going on is that men are much more likely to tell you, well, at a certain point, I was sent to an orthopedic surgeon because somebody thought it was some functional problem in my body. And women are much more likely to tell you, well, at a certain point, they thought I was crazy and they sent me to the psychiatrist. Neither the orthopedic surgeon nor the psychiatrist are the right specialist for somebody with multiple sclerosis. However, there are different paths that we send our patients on, which have to do with the bias we have as physicians as well. Let's move on to the future. Now, we have more and more digital applications that we're using in medicine. People measure all kinds of things. They self-measure themselves with their Apple Watch or with whatever devices and wearables they have. And a lot of the healthcare everyday data acquisition is going to happen remotely. And some of you might actually be working on that. And I have a few tales of caution for this because it is a very interesting evolution, but we might also reproduce bias in ways that we are not even aware of. And this is the work by Joy Buolamwini from MIT. And what she did is she looked at facial recognition software, which is starting to be employed in all kinds of different things. And we also start employing it in some things in medicine. But of course, it has implications way beyond that. And what she did was, she's a Black woman. She tried to use one of those facial recognition software, and the facial recognition software didn't recognize her. Then she put on a white mask, and the facial recognition algorithm recognized her. So she said, okay, there's something deeply wrong going on here. I need to investigate what this is. And so what she did is she developed this panel of individuals. These are all members of parliament, and you see from different regions of the world, they go from very light skin tone to very dark skin tone, women and men. These are blurred, these are not blurred, to see how does the facial recognition software deal with different conditions. And spoiler, and not surprising, if you are a man with light skin, the algorithm does really well, right? There's very few mistakes that are happening. You can see here the error counts, and the error counts are quite low. And then there's different types of algorithms. Some are a bit more, they don't like women as much, and some don't really like Black people as much. So what happened is we have this area here. So light females, so these are women with light complexion. Some algorithms do well, others don't. And then there's males with dark skin. And also, again, some algorithms do well and others don't. If you're a woman with dark skin, well, almost no algorithm will work for you. What does that mean? It has a lot to do, of course, with how the algorithm was trained, because if the algorithm was trained on a panel of mostly white male faces, that's what the algorithm is gonna recognize in the best possible way. If in your training algorithm, there has been basically no women with dark skin, of course, the algorithm is not very good at recognizing that. And that's what she's seeing in here. But that's also something that, if we're not aware of it, will impact the precision of the algorithm. And this doesn't just go for facial recognition, it also goes into medicine. And what I'm showing you here is a chatbot. There's quite a few around there. Maybe some of you have actually tried some of these chatbots. And what happens is you can input symptoms that you're having, and the chatbot will give you suggestions about which possible diseases you could be having. So for example, if you say, I'm a 56-year-old person, I smoke 10 cigarettes a day, I've had pain in my left arm for the last hour, and now I'm feeling sweaty and sick. Now, and then you say, I'm a man. The answer the chatbot is going to give you is you could either have a pericarditis, which is an inflammation of the heart. You should go to the emergency room. The second one is you could have unstable angina, which is also, again, a perfusion problem. So the blood in your heart doesn't flow properly. You should go to the emergency room. Number 3 is you could have a gastritis, so a stomach flu. You can go to your GP tomorrow. You could have a panic attack, stay at home and breathe. And number 4 is you could have a heart attack. So you should also go to the emergency room. I would argue with you that probably a person that gets these answers is going to go to the emergency room. Now, if you tell the algorithm you're a woman, this is what you get. Number 1, you have a panic attack, stay at home and breathe. And number 2, you have depression, which you will probably have if you had a heart attack and did not go to the ER. Now, what's happening here? I don't think the algorithm is consciously trying to kill women. What is happening here is exactly what I showed you before, that, of course, these algorithms are trained on historical data, and I've shown you that there is a bias in diagnostic times in the medical system. So if we use historical data that are 15, 20 years old, and we don't correct for this bias, or at least we're not aware of this bias, what this algorithm is going to do, it's going to reproduce what we have there. What I'm saying is not that this for the women does have to look exactly the same as for the men. There are probably some differences, but it is also true that if we're not aware of the delayed diagnosis or the wrong diagnosis we did in the past, we might simply reproduce them. So this goes for all kinds of chatbots, really, not just the ones that tell us about our symptoms. Another one, and that goes even a step further, is device malfunctioning. So we've seen that, interestingly, during COVID. So COVID has shown us a lot of things, most of them not really nice about the healthcare system. And it has also shown us that a lot of our devices might not be as inclusive as we would like them to have. There were already some discussions about the ability of oxygen saturation measurements. So what you see, these machines here are pulse oxygen measurement machines. So they measure how much oxygen you have in your blood. Probably most of you have heard about them in the COVID pandemic. There were already discussions about whether there's a sex difference in these in the past. So if they're able to measure as well in women as in men. There is no good data on that. But what was very clear during the pandemic is that skin color plays a huge role. So there's data now, and this is from 2020, that basically when you have darker skin, the oxygen measurement is less good than when you have lighter skin. So it's not just a gender factor, it might actually be a combination between potential differences at the sex gender level, in addition to ethnicity and to the color of your skin. So your devices might not work as well as they should, or as you predicted, if you don't have a diverse population testing them. Now, if I haven't convinced you until now, I still have some very compelling examples for the last few slides. And these go about drug development. This is really something that has caught a lot of attention in the media lately. Sometimes it's a bit simplified, but in principle, the thing is this. So this is, again, data from the 90s. It's historical data again. And this is a very large study that had been done at the time to understand whether digoxin, which is a medication for heart failure, it helps the heart pump stronger, basically. This medication was tested to see if it's safe. So what happened in this very large population, individuals got either digoxin at a certain concentration or placebo, which is basically an inert control, something that looks the same but doesn't do anything. And what you can see here is that digoxin and placebo are just as safe. So there's not more people dying using digoxin compared to placebo. They're also not less, but in principle, it's just as safe as taking nothing at all, which is great. I mean, we're happy as physicians if the medication doesn't do anything bad. Then what happened is that digoxin was deemed safe, and a lot of people started using it. It was prescribed a lot to people with heart failure, and especially women started to have side effects, and some of them had deadly side effects. So 5 years later, people from the same group took the data again and reanalyzed it, this time splitting it by biological sex. And what happened is what they saw was that the digoxin was actually good for men. So men taking digoxin, which are these ones, did better than men taking placebo. So it was safer for them. It actually helped them. But when we look at women taking placebo were safer than women taking digoxin. So actually, digoxin was bad for the women at this concentration. So digoxin is not bad in principle for women, but this concentration was too high because digoxin has a very narrow effectivity range. So you need to check it and you need to dose it at a certain way. Now, why did we have this curve here if there is such a huge difference? Well, because women only made up 25% of the study. So this difference, which is bigger than this one, was statistically invisible at the moment where you have, but this group is made up of 75% of the participants, and this group is 25% of the participants, and you put everything together, you get this. While in reality, what we're seeing is this, and this should actually help us tailor our clinical therapies better, because if we know this, we can say, okay, women might need a lower dosage, we need to monitor much more so that we can get a result like we have in the male population, in the female population as well. Now, This didn't just apply to digoxin. This is data from the late 90s, early 2000s. It applied to a lot of other medications that in general had more side effects in women than in men. What I point out here, it's a very rare arrhythmia that is a common side effect in women. So this was the reason for side effects in a lot of these drugs. As you can see here, these are all kinds of different things. We have antibiotics, antihistamines, gastrointestinal, so it can be any kind of drug really. And the problem here was that in a lot of these cases, medication hadn't been tested on female and male animals, and women were not included in clinical trials, but then the final product was given to the general population, and of course, that didn't work out so well. We're doing a lot better now. So in most clinical studies, women are included, and they do, the analysis is getting better. However, this is data from the COVID pandemic. It's not always as good as it looks, because in the moment of panic, we go back to our old ways. And this is data that we are collected ourselves in the year 2020 from January to January 21. And as you can see, when you look at registered trials, only about 1 in 20 said that they would look at sex and gender as an analysis criterion. So the moment the pandemic hits or the moment there's panic, we move back to our old ways of doing things. Again, as I said before, also here, what can you do? It's important to know your samples and your participants. It's important to include at least both sexes. If you want to measure gender, think about what it is that you want to measure. It's not easy, but it's doable. It's important to know what it is you're measuring. Sometimes it's helpful to consult experts. I'm not the only one out there. There's really a lot of people who are going in this direction and can help you design your work, disaggregate your data. I think the digoxin was quite compelling in that. Please stratify your analysis. Let us see if there's a difference between the female and male participants and report it. It's still not happening as much as we want. And of course, talk to your colleagues about that. Now I have a last 2 points and then I'm done. And then I would like to hear a bit from you is how far is the context important, right? I showed you initially that the EU doesn't just look at content, they also look at context. So why do they do that? This is data from my colleague Mathias Nielsen in Denmark, and he looked at how much does the makeup of a research team affect the likelihood of having a sex and gender sensitive analysis? And he looked at 1.5 million papers in PubMed, so quite a few. And they looked at in how far does the fact of women participating in research teams as first authors, last authors, or members of a group affect the ability to have a sex and gender sensitive analysis. And what you can see clearly here is if women were on the team, you were more likely to have a sex and gender sensitive analysis. Does that surprise you? I would say not really, because although we want to be really objective in our work, we're still humans, and the problems we see and the questions we're asking are affected by our life, by our decisions, by where we come from. And so it's not a surprise that when it comes to the discussion of racism in medicine and minority health in medicine, we have more representatives of this group seeing the problem, because if you're mainstream, you might not see it. If you're a woman physician, you might see the problem in your patients more than you might otherwise. It's not necessarily this way, but it is easier to see certain problems. And so if you have more diversity at the table in your teams, in medicine and in other fields, the questions you'll be asking might be more relevant to a larger group. We already talked, it was already mentioned in the introduction, so I'm not going to talk about the gender equality plans because you already heard about that. We can pick it up if it's important. So we'll conclude with this. There is a connection between content and context. So having diverse teams might enhance the work you do. And so consider also who you have on your teams when you try to solve problems, because that changes what your product will be like. And with that, I would like to thank you, first of all, for your attention, and want to know if there's any direct questions before I would like to briefly hear from you. I'm going to divide you into 5 breakout rooms for 5 to 10 minutes, where you can start. Well, first of all, briefly introduce yourselves. And what I want to know is, did you encounter any of this in your work already, or do you think that it could affect your work in the future? So I'll give you 5 to 10 minutes to exchange, and then we'll call you back in the general session. And it would be great if 1 or 2 people from every team can say a few words about, does it matter yet? Do you want to include it? How would you like to deal with this in the future? So it would be really nice to hear briefly a bit of feedback from the 5 rooms. And yeah, I would ask you, I don't know exactly who was in which room, but if you feel like it and you're brave, please let us know what you discussed in your room.
¿Animaos alguien? Venga, sí, Fabián.
Thanks for your presentation and thanks for explaining us all this kind of genre. And I have a question about how to apply the main discussion in this group, subgroup, how to apply these ideas for the each day, for every day. It's okay, everything is okay in theoretical part, but how we can apply all the things to the real life.
Yeah. Well, I think the point is it will not happen from one day to the next. So you cannot apply everything from one day to the next. And I think it's important. I showed you a lot of points and a lot of examples also because this gives you an overview of all the things that can be considered, right? So it's like if you wanted to do this properly, this is kind of where you want to go. I think what you will have to do in your process, especially if you start on a topic where you've never considered looking at sex and gender before, you will have to pick some areas where you can start with, and that are most immediate. A lot of times it's where there is already some research, there is already some previous data that can point in some directions. You will have to make some choices based on what is possible, how big is your sample, which kind of questions can you answer, which kind of data can you acquire or is already there. So there's also practical answers that define what you can do in terms of research and what you can. So I think it's important to realize that nobody expects you to go from 0 to 100 in a few months, but this is a process. And interestingly, what I experience in the long time that I've done this work is a lot of times people start with like a question, like a small question. They start working on this and they start finding interesting results. So that's what I mostly enjoy, is when I see people who are like, okay, I gave it a try. I had a look, we had some data and we started looking at this. And then a lot of times they actually find something interesting and they start building on it. And then the more you build on it, the more you can also look at, well, what do I want to add? How much more complexity can we do, and so forth. So I think it is important to see this as a sort of path where you start out with addressing some of the questions, and then as you move on, you incorporate more and more. And I think that's a much more realistic way. So what I show you is, of course, I would say 100%, but high achievement. It is a process to get there. Nobody does it overnight.
Thank you.
Thank you. Celine?
Yeah,
thank you. Thank you so much for your presentation. I would like to ask you like a kind of advice because, well, I was saying that I work in the agricultural field research. So sometimes it's kind of difficult to mention this gender dimension. And I personally, in my personal life, and I found really important this thing, and I go frequently to topics or whatever to speak about this. But I was wondering, how can we introduce this gender dimension in this kind of research?
Yeah. So there is actually on the Gendered Innovation website, if you go on it, I assume most of you know it, but if you Google gendered innovation, it's the first thing that comes up. We actually did, in our last round of cases, we actually developed one for the agricultural field. So that was done with our colleague Margreet van den Burg, who works here in Wageningen University in the Netherlands. And they specifically did a case for the agricultural field where she was looking at gender aspects in this field. So I think that might be a helpful primer, because what we try to do with our case studies is, of course, point out some things that show in how far looking at sex and gender can improve your work in a way, or bring up new ideas. So I think that might be quite helpful for you, because it's a worked out example. And with those, it's usually easier to get people on board if you can show that there's already some work and this is how it could be done and so forth. So I think that could be helpful for you.
Okay, thank you so much.
I have one question. Hi.
¿Alguien más?
I love the presentation. That was great. Thank you very much. Sometimes when you do clinical work or preclinical work, we have to work with big cohorts of patients, and these have a historic record that patients have been introduced in the cohorts for many years. So sometimes there isn't equal numbers of men and women in the cohort. So, and you have to work with the data they have. So, and if they are not big enough, you don't get sufficient number of patients to get statistical results. So how would you approach that? Is it enough to disaggregate data, but then you might not have enough data for one sex, or how do we go about with that?
Yeah, I would say it's a bit of a tricky one because it's a reality that we're facing a lot of times. I would say the thing with cohorts is, at least in my experience, a lot of times it's not so much the underrepresentation, because the groups are maybe even not equal, but they're relatively big, so you can do that. But a lot of times you don't have all the variables that you need to do your work. And this is a bit of the problem that I think is mostly connected to cohort. So we're also doing some projects where we're thinking about, okay, which new variables could you introduce? But there is a bit of literature from Canadian. I can share that afterwards with Marusha so she can share it with you. There's a few colleagues that try to work with cohort data and try to use some of the data that's in the cohort as proxies. So that's what the first best thing to do is. And of course, this is usually a first step you need to do to highlight what you're missing, because at the end of the day, the only thing you will do in the long run is you would probably have to introduce some more variables in order to do this properly. But you need to get there, and you need to convince the people who are in charge of the cohort that you need this additional data. If you go there and say, like, okay, I want to measure gender, they're like, why? And so I think it's really a bit of a process. And so what usually happens is people try to do this with the available data, so you can highlight what is missing. You can highlight that based on the literature, and then you can say, well, that means that going forward in the next wave where we collect data again, we should add this and that. So usually in every wave, you have some freedom to change a little bit. It's not a lot, but usually you can introduce some new questions, and that might be a way to go about it. When it comes to the historical fact of the underrepresentation, that's a tricky one. So we have that, especially like say in the oncological field, there is especially historical cohorts where women were highly underrepresented. Not necessarily that much in the cardiological field, but we also do have that. And here it is really a question of what is feasible, and what we can only advise here is really work closely together with a statistician to see how much robust data you can actually get with the cohort that you have, because it also doesn't help to do bad statistics, I would say in quotation marks, that kind of produce some kind of data that's not reliable. It's actually counterproductive to what we want. I mean, we want good science and good reproducible data. So I think in this respect, what we have done in some studies, and I know some of my colleagues have done, is you really work together with a statistician. You see what is the most parsimonious model we can design with the numbers we have, so that we can still have enough statistical power to actually say something that makes sense. But we will have to reduce, for example, the number of variables we can include in something like that. So in this case, I would definitely advise for robustness and sound methodology, with some cuts you have to make on maybe the layers you would like to investigate. So that's a bit of it's not an ideal situation, but it is, I think, what you can probably do here.
Okay, thank you.
You're welcome.
Hello, can I do a question, please?
Sure.
Thank you, first of all, for your clear presentation. In our room stands up a question about how can we apply this gender dimension to the energy systems and energy technology, because in my case, I am working on developing the glass for the solar panels, and I don't know how or what has to any relation with the gender dimension?
Yeah. So I think in your case, it probably has more to do with the impact. I think the dimensions you probably want to be looking for is more of the impact of your innovation rather than the innovation in itself. So I would say like the solar panel in itself is not different based on sex. But the impact that your technology can have on the market and the way you market it and the way it will be applied and who has access to it and you know which kind of impact it will have in the long run, that has definitely gender dimensions. So I would definitely keep that in mind when designing your product, when marketing your product, when seeing who it is accessible to. If you do market research, include diverse groups of people who are you're targeting. So your targeted market research should definitely be addressing diverse groups. So I think all of these aspects, which are more gendered aspects than sex-specific aspects, should be taken into account when going. So I think it's more of a when it goes about implementation, that's more where you want to consider the gendered aspects. But even at the developing phase, depending on what kind of, you know, are you developing, I don't know, panels that go on a roof? Are you developing panels that will go on a balcony? Are you developing like small panels that are portable and can be used in developing countries? So depending on what your target is, you should definitely include a most diverse group with looking at gender diversity, age diversity, and so forth already when you're developing this, because sometimes there are surprises in doing that.
Okay, thank you very much.
You're welcome.
Si no os animáis, vamos a ir cerrando la sesión. Sin más, quería agradecer. Thank you so much, Sabine, for such a brilliant presentation, very in-depth. And as I was saying, this is really important for so it is only a starting point, and from here in ADItech, thank you all, and as well we will provide you with all the references, and so you can start thinking with new or looking to your same research with another new eyes. So muchísimas gracias a todos, muchísimas gracias, Sabine.
Okay. Thank you very much. If you have any questions, please feel free to get in touch, and good luck with your future endeavors.
Thank you. Bye.
Bye-bye.